If you've spent any time on GM tuning message boards over the last 25 years, you know the legend of highway mode. It was a fuel-saving cheat code engineered by General Motors, programmed right into their engine computers. The legend says that because of strict EPA emissions laws, GM was forced to lock this code out on every single car sold in North America. For decades, tuners accepted this as gospel. We were told you had to look at Australian Holden ECU files to find this lean cruise actually working, and that American cars were completely blocked from using it. But today, we are rewriting history. We dug deep into the actual factory ROM chips, and we found proof that GM didn't just leave highway mode turned on for North American cars. They engineered incredibly specific, tailored loopholes to sneak it past the EPA. Today, we're looking at the code, the desperate automotive landscape that created it, the California Compromise, and how Australia kept this banned technology alive all the way into the LSV8 era. Buckle up, because we are busting a 25-year-old tuning myth. To understand why GM had to be so secretive about highway mode, you have to look at the absolute panic happening in Detroit in the late 1970s and early 1980s. Automakers were getting squeezed in a vice. The gas crisis demanded better fuel economy, and the newly formed EPA demanded drastically lower emissions. Automakers tried some wild, highly publicized experiments to survive, and most of them failed miserably. Take Chrysler's famous lean burn system, introduced in the mid-70s. Chrysler tried to run their carbureted engines at an ultra-lean 18-to-1 air-fuel ratio, so they could meet emissions without using catalytic converters. To control it, they bolted an analog spark control computer directly to the outside of the air cleaner. The problem? Carburetors couldn't precisely control fuel distribution, and bolting a primitive, heat-sensitive analog computer directly above a boiling hot intake manifold was a recipe for disaster. The computers cooked themselves, the cars ran terribly, and owners eventually ripped the systems off. Then in 1981, Cadillac tried to save fuel with the infamous V864. It was an early attempt at cylinder deactivation. It used electromechanical solenoids to disable the valves on specific cylinders while you were cruising. But the primitive computer management of the era simply couldn't process data fast enough to smooth out the transitions. The cars bucked, jerked, and stalled so badly that it became a massive PR nightmare for GM, and mechanics routinely disconnected the solenoids just to make the cars drivable. So, when the TBI and TPI fuel injection systems rolled out, GM engineers took a different approach. No flashy marketing, no clunky mechanical solenoids, no analog computers baking on the intake. They kept the solution entirely digital, completely invisible to the driver, and buried deep inside the software code. It was called highway mode. Because electronic fuel injection was so much more precise than a carburetor, GM knew they could safely suspend normal O2 sensor feedback during a steady highway cruise and lean the engine out to 16 or 16.5 to 1. This would save a massive amount of fuel, but there was a catch. Running lean raises combustion chamber temperatures, which creates a massive spike in NOx, or oxides of nitrogen, the gas that causes smog. The EPA cracked down hard. To appease the feds, GM locked this code out on the vast majority of their fleet. Take a look at this factory computer calibration for a 1991 Pontiac Trans Am GTA. The highway mode AFR table is fully populated, commanding a lean 16.0 to 1 mixture. But the code is completely neutered. The disable if miles per hour parameter is set to 255. The computer won't lean out the fuel unless you are breaking the sound barrier. And just to be sure, GM also locked out the highway spark advance by setting the minimum coolant temperature to 304 degrees Fahrenheit. Unless your engine is physically melting down, it's not getting the extra timing required for a lean cruise. This is what tuners have seen for 25 years. This was GM burying the code. But here is where the myth falls apart. They didn't lock it out on everything. Enter our first piece of evidence, the factory ANTT broadcast code for a 1989 5-liter F-body with an automatic transmission and ultra-tall 2.73 highway gears. Look at this factory code. The minimum speed isn't 255 miles per hour. It's sitting right at a totally normal 52 miles per hour. When you hit that speed at low engine load, the computer bypasses 14.7 and commands a wildly lean 16.6 to 1 air-fuel ratio. But a lean mixture burns incredibly slowly. Because that Camaro with 273 gears was barely off idle on the highway, it was heavily lugging. To keep it from misfiring, GM programmed the computer to dump in a massive 11.25 degrees of extra ignition timing to give that slow-burning fuel a head start. And it wasn't just lightweight, aerodynamic Camaros. We also found this code fully enabled in the ANLU calibration for the heavy 1989 350 Police Caprice. For police departments, highway cruising range and fleet fuel budgets are a massive priority. GM somehow proved to the EPA that this specific engine package could run lean on the highway without violating the NOx limits, allowing them to use this loophole to hit corporate average fuel economy standards. If you think GM just copied and pasted this code across the board to hit those fuel economy numbers, look at the factory AXKW calibration for the exact same 1989 5-liter F-body, but this one is equipped with a 5-speed manual and 308 gears. It commands the exact same 16.6 lean cruise. But look at the Highway Spark Advanced table. Instead of adding 11 degrees of timing, GM adds absolutely 0 degrees. 0. Why? Physics. The manual car with 308 gears cruises at a noticeably higher RPM. The piston is moving faster, creating more turbulence, squish, and swirl inside the combustion chamber. This natural turbulence speeds up the flame front, meaning the engine doesn't need that massive ignition crutch to finish the burn. This proves GM engineers were highly tailoring the highway mode math to account for the exact mechanical load of different drivetrains. But the ultimate holy grail of emissions tuning history is our final bin file, the ANTU calibration for an 89 B-body with California emissions. California's CARB regulations have always been notoriously strict on NOx. Running a heavy B-body at 16.6 to 1 in California would have failed certification instantly. So did GM lock it out with the 255 miles per hour trick like they did on the GTA? Nope. The code is still enabled at 52 miles per hour. But GM completely neutered the tables. Instead of 16.6, the absolute leanest this California car is allowed to go is 15.5 to 1. That is barely leaner than a standard cruise. And because it's not that lean, it doesn't need extra timing, so the Spark Advanced table is almost entirely zeroed out. This was the ultimate compromise. They leaned it out just enough to squeeze out maybe 1 extra mile per gallon to appease the federal CAFE standards, but kept it rich enough that combustion temperatures wouldn't spike and create illegal California smog. As the 1990s rolled on, OBD2 became the standard, and the EPA's NOx regulations became so universally tight that GM finally had to kill highway mode completely in North America. By the time the legendary Gen 3 LSV8 hit the scene, lean cruise was wiped from the American operating systems. But down in Australia, it was a completely different story. Holden was stuffing the same American-built 5.7-liter LS1s into their Commodores, and they were managing those engines with the exact same Warren-built GM computers, specifically the legendary 411 PCM. However, Australia's emission laws at the time prioritized fuel economy and CO2 reduction over strict NOx output, So, Holden engineers kept lean crews alive. If you open a factory Australian operating system in HP Tuners or EFI Live, the lean crew's parameters are fully functional. Holden programmed their LS1s to lean out to around 15.5 to 1 on the highway, adjusting spark timing and closely monitoring O2 sensor switching to maximize range in the vast Australian outback. Today, this Australian connection is a massive asset for the swap community. If you are running a standalone 411 PCM in an off-road LS swap, tuners will often flash a Holden operating system onto the computer or apply a custom patch to an American OS just to bypass the US lockouts. Once you change the region code or apply the patch, the 411 wakes up, and suddenly your 400 horsepower LS swap is pulling down almost 30 miles per gallon on the highway. To see this magical code at work when it is woken up, take a look at this real-world footage. The car is cruising at a steady highway speed with the cruise control turned on. Hooked up to the dash is an Innovate Motorsports LM1 digital air-fuel ratio meter. Right away, you can see highway mode in full effect. The meter shows a car running a lean air-fuel ratio of approximately 16.5 to 17.1. The driver actually used Tuner Pro software to specifically target that 16.5 AFR. But remember those catalytic converter safety timers we talked about earlier? Watch the meter. Eventually, the ECU commands the AFR to drop back down to around 14.7, which is a standard stoichiometric mixture. The driver explains that the car stays in this richer stoich mode for about 20 or 30 seconds. This gives the exhaust a chance to cool down. Once that timer resets, the computer instantly goes back into highway mode, and you can see the AFR jump right back up into that 16.5 range. Even while running this lean, the driver confirms the car isn't running hot. By simply utilizing this dormant factory code, they note that the car gets an improvement of a couple of miles per gallon on the highway. For 25 years, the tuning community thought highway mode was completely banned in the US from day one. The truth is, GM engineered brilliant, platform-specific loopholes to keep it alive right under the EPA's nose, before finally passing the torch to Australia in the LS era. If you are tuning an older OBD1 system today for an off-road or emissions-exempt vehicle, like the TPI retrofit I'm currently wrapping up on my '78 Corvette, you can go into your tuning software, undo those 255 miles per hour lockouts, and wake this hidden code back up. It is one of the most satisfying ways to squeeze modern efficiency out of an old-school setup. Have you ever dug through the ROM chips of an old GM ECU or messed around with Australian operating systems on an LS swap? Let me know down in the comments. Hit that like button, subscribe for more deep dive automotive tech, and I'll see you in the next one.